Good day everyone, today we shall be discussing modular arithmetics, a system where numbers bundle up on getting to a point called modulus. A very good way to understand this topic is to visualize a 24 hours digital clock. If you would read from this clock, you would read in hours. You start from 0, 1 hour, 2 hour, 3rd hour, and so on. You kept on reading 21, 22, 23. On getting to 24, the number bundle up and return back to 0. So 24 will be 0, 25 will be 1, 26 will be 2, 27 will be 3. Then you keep on going, then 45 will be 21, 46 will be 22, 47 will be 23, then 48, being the multiple of 24, bundle up again, it will wrap up and turn back to 0 again. This system of counting in modulo is called modulo 24. Mode 24, simply mode 24. So modulo 24 set starts from integer 0 till 23. A number before the modulo itself, 24. 23 is the number before 24. So you start counting from 0 and you end at 23. So every number that's a multiple of 24 always wrap up to give you a 0. So in general, a number in modulo n will contain 0, 1, 2, 3, and so on till you get n minus 3, n minus 2, then n minus 1. That is a number before the modulo itself, which is n. If you'd notice, all the numbers in this set of modulos are starting from 0 and ending a number before the modulo itself, meaning we are dealing with 0 and all positive integers. Though we can evaluate a negative number, say minus 7. So minus 7 modulo n now, if I need to find the value of minus 7 modulo n now, all I have to do is, since the value here is negative, all I have to do is keep on adding the value of the modulo until this n is absorbed. This minus is absorbed, meaning this becomes n minus 7 modulo n. And since there are countless numbers that can be in place of n minus 7 modulo n, so we say this is not, minus 7 is not the only value that can be here, but however is equivalent to the value. So it's equivalent to this value, or you simply say it is congruence. So, meaning we can interpret this, or this is read as minus 7 is equivalent or congruent to n minus 7 modulo n. I hope that is very clear. Let's consider the division of all positive integers, including 0, with 3. We shall be taking note of the remainders. So, 0 divided by 3 is 0 remainder 0, 1 divided by 3 is 0 remainder 1, 2 divided by 3 is equal to 0 remainder 2, 3 divided by 3 is equal to 1 remainder 0, 4 divided by 3 is equal to 1 remainder 1, 5 divided by 3 is equal to 1 remainder 2, and so on. If you take a look at the set of the remainders, you would realize that the remainders are starting from 0, then 1, then 2, then 0 again, then 1, then 2, then 0 again, 1, and 2. So, when you consider this set, you realize from the definition of modulo, or the set of number, or the kind of numbers that belongs to a modulo, you realize that this is a modulo 3 element, which implies that had we divided by 4, then we will have gotten a modulo 4 element, which is 0, 1, 2, 3, a number before the modulo. Then that of modulo 5 is equal to 0, 1, 2, 3, 4. With all this being confirmed, given that n is divided by d, and of course gave us a value, the quotient, and giving us a remainder, say r, then the modular system interprets this as n modulo d is equal to r, where the d there is called the modulo or the modulus. Anyhow you call it is correct, modulo or modulus. Let's solve some examples on how to evaluate numbers in modulus. While we solve this example, it is important for us to always remember that at a count that is equivalent to the modulo itself, the number or the count wrap up to give us 0. It's wrap up or it bundles up. That's the point of bundling. So it evaluates to give us a 0. To solve this question, 6 modulo 4. We know that 6 is not a value in modulo 4. Of course, the values in modulo 4 are 0, 1, 2, 3. So the first thing you have to do is reduce this value to a value in modulo 4. How do we go about it? We have to extract the maximum 4 we can get from 6. So this becomes 2 plus 4 modulo 4. So this now can be rewritten as 2 modulo 4 plus 4 modulo 4. And 2 modulo 4, don't forget that what this 4 modulo 4 and this is the same count as this, so it becomes 0. So your value here, the equivalent value for 6 modulo 4 is 2 modulo 4. I hope that is clear. In the case of 24 modulo 4, of course, extract the maximum 12 we can get from it. So 24 modulo 12 can be written as 0 plus 12 plus 12 modulo 12. And this is 0 plus 2 times 12 modulo 12. So all this multiple of 12 becomes 0. Then I have 0 plus 0 modulo 12. So this is equal to 0 modulo 12. I hope that's very clear too. Let's manage this last question here. It is very important for us to note that just like the normal arithmetic, we can perform all our operations on modular arithmetic. Multiplication, addition, subtraction, taking the root, raising to power. We can perform all operation on it, except that the division is a bit complex. It's not so convenient to do. So to do this now, this question we've gotten here, we know that x raised to power 2 is equal to 1 from what we've gotten here. And of course, we know if we evaluate x here, x will be equal to plus or minus 1. So, which means we are having x equal to plus or minus 1 modulo 6. So, this means that my x is equal to 1 modulo 6 or minus 1 modulo 6. Of course, we can have 1 modulo 6 in the modular system of 6. Of course, this is correct. This is correct, but this is a problem. We can't have minus 1 in modulo 6, so we have to keep on adding 6 until we absorb the minus. So this becomes 6 minus 1 plus 6 modulo 6, which is equal to 5 modulo 6. I hope that is very, very clear. That will be all for now. Please join me in the next video where we'll be providing solutions to these problems here. Don't forget to hit the subscription button, like this video and share. Thanks for watching.